Hello and welcome to Mindful Minecraft. I'm Andrew and this is our All the Mods 10 survival series. Last episode, we automated a food source and we used mechanical harvesters to automate our ingredient farming. We also got pretty busy with functional storage and integrated dynamics. I think I tried to fit a little bit too much information into last episode, especially given the length of the video. I'll try to be a little more thorough this episode and pace it better. Please let me know if the way I'm explaining things is making sense or if it's too scattered. It'll only make the content better. Speaking of, today I've got a good bit of stuff on the docket. I'd really like to use what I consider to be the greatest machine Create has to offer: the cart assembler and mechanical drill combo. I also want to make some cool turbine style windmills with Create so that we can upgrade our stress unit generation. Then we'll see what other kinds of mischief we can get ourselves into. We might even have a new location for our next industrial push. I'm feeling sustainability as our theme. Without further ado, episode 3 of All the Mods 10. Buckle up. Before we start today's task, we need a load of iron, and I mean a very large amount. But we aren't going to go mining to get it. We're gonna harness the power of our local villagers and support local business. We just need a small amount of iron and lava to start, but then we can scale this up as it pumps out iron. If you aren't familiar with Mechanism, it actually adds a really cheap portable tank. You just need 4 iron ingots and 4 redstone dust. We need to use this like a big bucket with 32 buckets worth of space. It'll get us enough lava for our easy villager iron farms. Holding the tank in your hand, sneak scroll, and it will change from tank mode to bucket mode and vice versa. These are super handy, so keep them in mind. You're going to use these a lot. Now go ahead and just collect your lava. Let's get back to the base and craft up our iron farms, and then I've got something special for you. These are going to cost us 5 glass panes, 2 iron ingots, 1 stone, and 1 lava bucket per iron farm. But these absolutely crank iron out if you make a ton of them. So try and scale this up and continually make these because you're going to need iron and these things absolutely pump it out. Go ahead and make a controller access point. We talked about these last episode and these things are super strong. Go ahead and place it down, and then place a few of the iron farms on top of each other on top of that. Then go ahead and link the controller access point up to your normal controller. We still are going to need some drawers to store our items from these farms. Let me introduce you to the compacting drawer. To craft one of these, we just need 5 stone of any kind, 2 pistons, 1 drawer of any kind, and 1 iron ingot. These have a ton of uses, but our main use is going to be with metal for today. This will take anything you have a nugget of and compress it into ingots, and then ingots into blocks. These are neat because they update whenever you pull from them or input into them. If we have 576 nuggets, that's 64 ingots, and that's 7 blocks. But these allow you to pull nuggets, ingots, or blocks out, and it updates the total amount left of each item. This is a great way to store your bulk of materials because we need nuggets, ingots, and blocks for all kinds of crafting recipes. That's super handy if you ask me. You don't have to individually make nuggets or make blocks or make ingots, it just does it for you. Now we need a place for the poppies that will also drop from this farm. Go ahead and get yourself 1 normal 1x1 drawer and make an iron downgrade. This just reduces the max items allowable in the drawer to become 64. Then you'll need a void upgrade. This just voids the excess items over the drawer's max storage limit, so kind of just like an overflow. Now we need a way to get our items from our iron farms into our storage system. This is going to be super simple. We're actually going to use the item pipes from the pipes mod. First, let's get our pipes wrench. This is pretty simple. We just need 2 sticks and 2 flint. Then let's craft the item pipes themselves. To craft a stack of 16 of these, we need 6 iron ingots, 2 droppers, and 1 redstone dust. Now let's go ahead and get this ready to pump the iron into our storage system. On the side of our iron farms we need to place our item pipes. Then we need to take our pipe wrench and right click the pipe where it's connected to the iron farms. When you see this little coupling here, that indicates that the pipe is pulling from that inventory. If there's no coupling, that means it's pushing into the inventory. There's one last step. We need to go to a village really quick and get some villagers. If you don't know, with easy villagers, you can actually just abduct villagers and they get put into your inventory.
Yeah, boy.
We just need to right click with the villager in our hand and pop it into the iron farm. And voila, we're making iron now, baby. Let's let this sit while we craft up our first grouping of components today. Like I said earlier, this has to be my absolute favorite create mod functionality. The cart assembler is an all-in-one tool. We can make a massive portable storage system, we can make farms with it, entire portable rooms, or we can make an extremely efficient mining contraption. We can put as many mechanical drills on one of these as we want and strip mine to our heart's content. But we need something to attach the drills to, so let's do that. Let's get our cart assembler crafted and then we'll go over how this works. To craft one of these, we need 2 logs, 2 andesite alloys, and 1 redstone dust. Go ahead and get yourself a few rails, a lever, a minecart with a furnace, some fuel, some building blocks, some super glue, and never forget your wrench. Now, our main usage of this cart assembler today is going to be with machines attached to it. But for now, I'll just show you how this is placed, how it moves, and how to pick it up. If we try to place our cart assembler just anywhere, it won't place. We need to place it on top of rails. Once it's placed, we'll be able to interact with it. Let's go ahead and put our lever down right next to it and turn it on. You'll notice that it accepts a redstone signal. This is how we activate our contraption and turn it into a big entity. But let's just turn that off for now. We need the actual contraption. Go ahead and place your minecart with a furnace down. Make sure it's under the cart assembler before you do anything else. Now that we have our cart down, we can start building on top of it. Go ahead and grab your super glue and your building blocks. Place the first block on top, and after that, remember to put your glue into your offhand so it auto glues all the blocks. Now we can just freeform build or attach things to that block. I'm gonna go ahead and just make a random block ball, and then we'll activate our cart assembler. Pull the lever cronk. You can see the cart assembler push the cart itself upwards into the blocks we placed, then it's active. I use the minecart with a furnace because we can just right click it with our fuel and it starts moving. Now it's moving and it's going crazy all over the place. We need to fix that. Go ahead and right click the cart itself with your wrench. It'll pick up the entire contraption. You can name these in an anvil and keep them in your storage. And remember, they'll retain their storage when you do this. But now we can turn the lever off and place this back down. On the side, we have rotation options. For our mining contraption, we want to make sure we lock the rotation so it stays straight no matter what. Now if we pull the lever again and make sure it's fueled, it'll start moving, but this time it stays locked on the cart and doesn't rotate all around. Alright, so we're here in a new room. I ended up putting all of our resources that I've mined, like raw resources, into these compacting drawers. This just ensures that no matter what, we'll never run into a problem with transporting materials out of our new contraption here. But I will say, this can get clogged. this smart chute that goes into a controller access point that is hooked to all of these. It's just my personal favorite way to make sure everything gets put where it belongs. But sometimes it can clog up, and the best way to stop that, if you don't have a drawer for something, is a list filter. Now, these list filters, we're actually going to use them on our contraption. But in order to craft them, you just need 2 iron nuggets and 1 wool of any kind. And you just right click with it in your hand, and you'll notice I've got a couple things here. So there's a deny and an allow list, a respect data, and an ignore data list. So these are just relevant if you're dealing with NBT data, which we're not. And then these change whether or not it pulls or doesn't pull. So since we have it on deny, rails, and charcoal, when we place this in here, it's not going to pull our charcoal out or our rails out. And this is just really important because we don't ever want to pick this up and take it somewhere and not have our rails or our actual like fuel source, because it can just get a little frustrating. Now to build this, I normally like to start with just 3 rails. It's a good middle ground between your machine falling off. So to begin, we can take some building blocks. We're gonna just do that thing where we place 1 block on top, and then we're gonna build out from there, retaining a 3 block tall height. And then we're gonna move forward. We need this spot for a deployer. And we can go ahead and move this. Come on now. These things are so frustrating sometimes. There we go. And then we want to just turn it so we have access to the filter. And then this one here, we're also going to place a deployer. Now, each of these has its own role. This one is going to place rails, so it needs to be 2 blocks above the ground. This one is going to place blocks if we need them, right? Because we could be tunneling through our mine and come across like a ravine. And if we don't have something placing blocks in front of where our rails are going to be placed, it'll try and place a rail, and then it's going to fall off into the ravine, and you're going to have to go get it. And it's not fun because it can fall in lava and it will sink. So now that we have these set up, what if we took another list filter and we actually made a filter, right? We need dirt, cobblestone, cobbled deep slate, and netherrack. You can actually just drag things into here from JEI, which is really helpful. That way you don't have to have everything in your inventory. Now we can take this filter, which we have set to allow, on this first deployer. This deployer will always pull and make sure it's got at least some cobblestone or whatever you're digging through to place in front of your rails. And then we're going to put rails in this filter slot and then put them in the deployer hand. That'll ensure that this actually places the rails and has some starting stock. Next up, we're going to need our drills. Now, this is a new machine for us, and in order to craft these, you need 1 iron ingot, 3 andesite alloys, and 1 andesite casing per drill. I like starting with 9. I think it's a good, like, middle ground once again, because it covers your entire footprint of your machine vertically and horizontally, and that way you still have room to walk down the side of it and pick your contraption up if you need to. So this is a good starting point. You can put as many of these on here. I'm eventually going to get this built up 5 high by 5 wide, and then off of that go 3 up, and then a giant strip mine set up on each side. We've got our basics set up here. We've got the drills, our frame, and then we've got our 2 deployers that are going to place stuff. Now we need a way to pick up our rails. And the best way to do this is by building a little extension that comes down and placing your mechanical plow. I would honestly say bring this out one more and make sure that there's 2 blocks between your assembler and your plow right here. Now to craft the plow, you just need 3 iron plates, 3 andesite alloys, and 1 andesite casing. This is just going to scoop these up as you move forward, put them into the inventory, and cycle them back to the deployer. You'll never run out of rails. I always just make sure to have extra rails just in case. Now we can probably glue this together. Oop, what happened here? Just click on you. There we go. And then we'll glue all this up. Run to the front here. And then glue those on. And then we can glue that up. And that up. Now it's all one piece. If we activate this, you can see it lifted. And it's all together. Now we need to deal with our storage and getting the items off of our contraption here. So, like I showed you before, we have a portable storage interface, our list filter, our smart chute, and it goes into the controller access point. And from there, it just distributes it to all of our drawers that we already have set up. So you can go ahead and just place this on the back. I don't know why it placed that way. Come on now. There we go. Now it's facing this. We have 1 block of separation in between. So this will be good. We go and turn that on. You can see it connects. Now we need a place to store all our items. So I'm going to start by just placing chests down the side. We've got enough for 1, 2, 3, 4. So 8 chests, 4 double chests basically. All the way down that way. And then we can go ahead and place 1 there, 1 there, and then just fill that in like that. And if you notice, I'm maintaining access to these filter slots, and I'm maintaining access to push our contraption. There's one final piece to this, and that's a white seat or any other kind of seat, doesn't really matter. To craft it, you just need a slab and a piece of wool of any kind, and you just place it on there, and now we can just sit on this and ride with it as it mines. This is super helpful. It just helps us stay with our contraption and keep it loaded. Let's do one final glue check and make sure everything's glued on, which it's looking like it is. That's good. Now we can go ahead and ensure that we have locked our rotation, which we have. We can turn this on, and then we can push it. Get out of there. You'll notice it just placed a rail. So we know it's working. Now, let's go ahead and go down into the mines with this, and I will show you exactly how this is going to work. We can come down here into our massive room we built for our bread and our milk spout. And we can come this way. I've been mining. This is my mining area for now. To place this, we probably want to dig out a little bit of a space here so that it'll place and not conflict with anything. So you just go ahead and put your rail down, and then put your contraption down. And then we need fuel. So we know we've already put our rails in here. Let's go ahead and put our fuel in here, and we'll take 1 because we kind of need to kickstart this. Oh, it didn't have any it didn't have any cobblestone to put down quite yet. go ahead and do this. Where'd that go? Oh, did it not place on a rail? This can happen sometimes. It's probably a good idea to make sure you have at least 3 rails to start and put it on. That way it's always got that first bit of movement. Go ahead and just push that. And you can see here, it's breaking the rail, and then it's placing a rail. And then if we mine over another hole like that, it should place a block. So you can see there, it places the block below, and then the rail right behind it. These are especially powerful when we go to the nether with them, because they're a really good way to like tunnel through and keep ourselves safe while also finding ancient debris. It's a pretty handy way to do it. It's also good to note that these can break up to obsidian. So anything that you can mine with a diamond pickaxe, this will mine. I haven't tried it on like all the modium or things of that nature, but when we do end up getting to the deep dark and finding that, we can test it out. Yeah, look, here we go. It's gonna keep placing over. If it feels like it gets hung up or it's stalling or stopping on something, it's probably just mining obsidian or Stella Arcanum. So don't worry about it too much. Okay, let's get on. We can ride this thing now. I'm gonna go ahead and just let this thing mine for a little bit, and I'll be back with you when we're ready to hook this back up to our storage and make sure that it transfers everything the way we need it to. Oh, here we go, look. This is another cool thing. It's not affected by water. You are, though. And you can still drown. But it's gonna get us through the water. Keep going. I'm about to drown. Oh. Oh. Oh, it just mined a silverfish. I heard that. Oh. It does damage things. So if there's like a mob or something, it will take the mob out. It's quite the interesting tunnel we've made. This is why I think it's so overpowered. Is you could just go ahead and mine right through and still place and bridge through water. And we made it to the other side safely. You can see we've gone quite a ways. But I'm just gonna let this go, and I'll be back with you in a little bit. We're gonna let it run for, let's say, 10 minutes, and then we'll head back and hook it back up to our storage system. So I let this mine for quite some time, and I want to show you something here. So I went ahead and I've kind of played forward and gotten as many resources as I possibly can from different mods, so that say we do end up like mining into an asteroid or something and we get some quartz somehow, it actually just has somewhere to put it and it doesn't clog our system up here. And then I did take this to the nether for a little bit, and I got us a little bit of glowstone, not much, but just enough to fill a spot. And I did find like a meteor out here somewhere. I think it was like that direction, and it had a ton of ancient debris in it. So I went ahead and put one in there. What else? Oh yeah, I've got these different mods. We've got our arcane crystals or gems, whatever those are called, runes, dark gems, and then I've got our modern industrialization stuff over here that doesn't have a compacted variant. Notice all these have like a 1x compaction. Anything with the all the ores tag will do that. Otherwise, they're going to require these simple compacting drawers. So keep that in mind if you do end up setting this up. But let's just go ahead and place this down. And then let's turn it on. I'm going to put our rails back in there. You'll notice this is just absolutely pumping everything into here. We might get lucky and see something change. What's it doing right now? Oh, torches. Yuck. Raw uraninite. So that's something we need to make a drawer for. It's looking like that doesn't have a compressible variant, so we'll pop it in one of these. And it's just pumping everything else in. Okay, it just finished. So the only thing that should be in here, if our list filter worked, is our charcoal and our rails. That's perfect. We can go ahead and pick this up. Push it off and just pick it up. No, don't mine through my base, man. Whew. That was close. Next time I think I'm gonna take the coal out. I don't know. That was sketchy. My goodness. We could just take that off for right now and pick it up. Well, actually, I should probably put my rails back in there. Lovely, lovely placement. Let's go ahead and put this back down. All right. Now that we've played with this and we've got some more resources, I think I'm going to move on and we're going to get into a new kind of industry. And for that, I've prepared us a really cool base and a new area. So I think it's time we sort of say goodbye to the mindful manor for a little bit and we go check out a new kind of mindful methodology. I want to talk about something near and dear to me for this week's Mindful Moment. As someone who cares for the landscape and the ecological health of schools that are within basically forests, I can tell you there are so many ways that we have left our mark as a civilization and society upon this beautiful planet. We've logged and burnt down entire rainforests. We've strip mined mountains and mineral deposits. We've demolished the Great Plains and polluted the open waters while extracting fossil fuels. There's countless cases of humans ravaging the natural world for industry and the wealth of power that comes from controlling these natural resources. There's always a more sustainable way to do something though, but the cost is sacrifice. We have market disrupting methods of production that are quelled by the large monopolistic companies and industries. For them, on an economic level, our planet is just a large cache with a limited amount of resources on and within itself. So there's a competitive advantage to controlling more of one resource than another country or region. Things like precious metals and lumber are finite materials. We may be able to grow trees, but the time in which it takes for a tree large enough for timber is on average 20 to 40 years. Each industry is dependent upon one another. From fuel to raw materials, a large combine harvester, for example, requires metals, electronics, rubber, plastics, and fuel. Each one of those materials is contingent on another long list of resources and processes to acquire those resources. With each step up the ladder of industry, the carbon footprint is increased and the overreach of humankind is ever present in the surrounding natural world. It costs more money to do something right, hence why these industries only comply when they're required by law and harsh penalty if otherwise. The only problem with that is that governments can't really do much about it because these companies basically control the economy. There's no end-all be-all way to perfect industry or globalization and create sustainability, at least not right now. Not under current world leadership, not under constant economic pressure, and definitely not with the standardized leniency that leaders of industry can use to continue profiting off of the natural world. As those same lumber trees we talked about earlier grow for 20 to 40 years, millions of other lumber trees are harvested and pollution surmounts. And by the time the next batch of lumber is ready to harvest, they're overtaken by air pollution. The mark the humans left on that forest have desecrated the soil. It's no longer fit to house those trees. And the trees that were replanted to be harvested are now dead, and they're not growing past that first decade. So they're too small to gain value from in the scope of manufacturing. The cost to harvest these trees becomes too high for the yield of material in the eyes of industry. The land is left raised, it's demolished, and certainly won't be restored within any of our lifetimes, unless we relentlessly criticize and condemn the methodology behind industry and globalization. You can learn what kind of items you're buying, how they're being produced, how they're being harvested, how the company commits to carbon offset, and how you can contribute to the change. You as a person or as a family can't make the difference necessary to close the carbon emission deficit. It's just unrealistic economically. And it's definitely not your personal responsibility to clean up after an industry's demolition of the planet. The ruling governments and the leaders of industry will tell you what you can do, even though they're the only actors on this ruined planet who carry the reach and the resources to make that change. This has always been the problem. So find a cause that you're passionate about in relation to environmental activism. Have your voice heard and have your impact felt on a grander scale. Advocate for sustainability in industry, protest for change, and boycott unsustainable practices and the people who fuel them. Use your knowledge, curiosity, experience, and understanding to create something sustainable. You're all creative people with a mind for problem solving and critical thinking. Why else would you be here in All the Mods 10? The main point of this mindful moment is to just spread awareness. We're going to take a step back and come up with creative solutions that offset our carbon footprint throughout our playthrough for each and every automation. With all that being said, we need to commit to our mission of closing that carbon emission deficit. We have access to an endless amount of resources and options to work with here. Sustainable clean electricity is our ultimate goal, but we need to go over these windmill bearings if we want that. If we look at our massive windmills here, we can notice a few things. There's 2 stacks worth of sail blocks on our windmill, and it's spinning fairly fast. I've prepared a little chest over here with our blocks that we're going to go over. We've got our windmill bearing, a stack of wool, 2 stacks of windmill sails, super glue, our wrench, a vertical gearbox, and a speedometer. To craft the new items, starting with the windmill bearing, we need 1 wooden slab of any kind, 1 stone of any kind, and 1 shaft. It's a fairly simple craft, and we're going to get a good amount of stress units out of this. Next up, we've got our windmill sails. They require 1 wool, 2 sticks, and 1 andesite alloy. These are what's referred to as a sail type block, and we get 2 of these for every 1 piece of wool. A sail type block is wool, or these frames, and you end up saving wool if you choose to craft the windmill sails. These also have some added benefit. We don't need to use glue in order to attach these to our windmill bearing, and that's a nice little addition. For every 8 sail blocks on our windmill bearing, we gain 512 stress units and we gain 1 RPM. The windmill bearing requires at minimum 8 sail blocks in order to spin, and we can have up to a maximum of 128 sail blocks. Let me demonstrate exactly how this works. We're going to start by placing our gearbox down, and then we'll attach the speedometer on the ground right here. Now we can go ahead and place our windmill bearing on top of the gearbox. I think we should start with the wool as our first type of sail block. If we place our first wool block down and try to turn it on, it's not going to spin. It's telling us that there's not enough sail type blocks, so we need to get our glue out and have at least 8 wool blocks attached. Now if we right click our windmill bearing again, it'll start to spin, but it's going super slow. Our speedometer is showing 1 RPM and the windmill bearing is showing 512 stress units. Let's make this faster. We can take our windmill sails and attach them to our little wool tower here, but we don't need our glue, so get that out of your hand first. I'm going to turn the windmill bearing off and then start putting these on our column of wool. Let's start with 8. Now you can see it's making 1024 stress units and it's spinning at a total 2 RPM. Another 8 sail blocks and we'll be at 1536 stress units and 3 RPM. Let's put all of these on here, minus the initial 8 that we had put on here of wool blocks, and then let's check it again. With a total of 128 sail blocks here, we're now at 16 RPM and 8,192 stress units. If you're so inclined, you can make a vertical wall of these windmill bearings and then extend out 128 blocks on each bearing, then link every single one of them up, and it'll all work just the same. That's an extremely efficient way to make a ton of stress units, but it's not as cool as building massive structures with a purpose. But that's just my personal opinion. We've got these giant windmills, and I want to connect each one of them together using the new chain conveyors. These are kind of like the coolest thing in Create right now. And I say that just because you can now transfer power easily using diagonal directions instead of just vertically or horizontally. It also seems like a fairly clean way to just transfer our stress units for the time being. And if anything, we're going to get style points. You get 2 of these with each craft, and that's just going to cost you 4 andesite casings and 1 large cogwheel. But we also have to connect these using chains. Luckily, we made those iron farms earlier and have a ton of ingots and nuggets to craft these chains up with. It's important to note, for every 2 2/3 of space in between our 2 chain conveyors here, it's going to require 1 chain. These, combined with the new frog ports that were also added, give you a cool way to transport your items. You can also ride them using your wrench by aiming at the chain and right-clicking with your wrench, providing you a pretty fun way to get around your base. But we're just going to be using these for stress unit transfer and easier connections for the time being. With our giant windmills and all of our stress units, we're going to convert this into electricity. Now, during the recording of this video, we actually got a few new Create add-ons updated and added to the pack. We're going to be utilizing Create crafts and additions today, and with that, we're going to need a few machine setups. First, we need to make mechanical crafters. These are used for so many things. We can auto-craft to a certain degree, we can make special tools and items, and we can configure them for a few big items. We're going to need 12 of these to start, but it's a pretty simple craft. We just need 1 electron tube, 1 brass casing, and 1 crafting table, and with that, we'll get 3 mechanical crafters. We'll make 12 of these and then grab a cogwheel, a wrench, and then we're going to go place these down. But to place these, we need to understand how to stack them to make certain patterns. If we open up JEI and we look at our alternator recipe, which this is what we're going to be crafting, This is how we'll be converting that wind energy into electricity. You can see that there's a certain pattern here, starting with 3 on the ground, 5 above that, 3 above that, and then a final one on top. Now, when we place these, we need to keep note of the arrows on the front. These are indicating what way our items are going to move and where they're going to end up. You can pull your wrench out and right-click on the arrows and they'll spin around and face a new direction. I always like to make sure that the arrows face downwards and then meet in the center on our middle row. Then I like to send everything down to the bottom row and to the left. Then I place a barrel or chest and the craft will get put in there when it's done. Now all we have to do is power this. You can see cogs connecting each one of these mechanical crafters together, so we just need to place a cog wheel to this on any available side, and then just run power to it. Now that solves our crafting problem, but what are we crafting and how do we craft it is the real question. Let's move on to create crafts and additions, where we'll be unlocking a new machine for hire and creating some new crafting components. We've gotten so much done today. We've crafted up some iron farms, we built a cool mining contraption, we've unveiled our new restoration project, we created clean renewable energy production using Create, and we've taken our first step towards crafting our first piece of electrical energy generation. But what if I told you that for everything we did today, we can make it better by using certain Create add-ons? That's exactly the case. Create crafts and additions adds some fun new blocks, new machines, a couple items, and 3 very powerful versions of energy. We have to craft one of these new machines in order to get any required materials for multiple new recipes added by Create crafts and additions. We need the rolling mill. This machine mills metal plates into metal wires, ingots into rods, and bamboo into straws. We'll get into those straws later on in the series, but for now, we're just worried about wire and rods. To craft the rolling mill, we need 2 iron plates, 2 shafts, 4 andesite alloys, and 1 andesite casing. This rolling mill is so handy, but it can be tricky to set up as it's not very clear as to how you actually get the items in or out. I usually use a hopper to input and right-click the rolling mill to get my final product. Now, if we take a look at our recipe for the alternator, we're going to see we need a few new components. We need spools of copper wire, iron rods, and we need capacitors. We only need the rolling mill for the wire and the rods, so let's craft up both of those really quick. To begin rolling, just connect the rolling mill to your power source, and then place a hopper on the top or on the side. Then put whatever metal plate you need a wire from into your hopper. It'll begin feeding the rolling mill with your plates, and as it rolls, you'll see you start to get wire. Let's let this finish and we'll just right click to remove our finished product. Next up, we can do our rods. Place any metal ingot that has a corresponding rod recipe into the hopper, and it'll begin rolling the ingots into rods. Let's go ahead and let this finish up, then we'll right click just like before and take these with us. Now that we've kind of gone over the basics of the rolling mill, we can go over how to craft our different wire spools. These are how we're going to make our copper wires usable. To craft a stack of 16 wire spools, we just need 2 iron plates and 1 iron nugget. Then we can take our stack of copper wire that we just made and place it around our wire spools like this. We're going to do this next part sort of rapid fire, but to prep, let's make a few more ingredients that we're going to need. We're going to need electrum, which is an alloy just like brass, but in order to make this, we can crush gold ore and silver ore into dust using an ore hammer, which, if you're unfamiliar with this, it's just a craftable tool. You just need 2 blocks of copper and 3 sticks. You can use other metals. I personally prefer platinum because it's so common and it provides the highest durability. Then we're just going to crush a stack of each, or however much you want. And then we're going to combine the 2 dusts in our crafting window. Alternatively, you can use your mechanical mixer. Then let's make 16 gold rods, 16 copper rods, 16 iron rods, and then we'll turn some of our electrum into plates and then wire. Finally, we need some zinc plates for the capacitors. We'll go over the capacitors in just a moment. Now, there's a few uses for this wire, but we aren't quite ready to go over that yet. we're going to need connectors, and that's going to require some of the capacitors and some gold rods. You can make the capacitors by pressing zinc into plates and then add them to one copper plate and one redstone torch in this pattern. This will get us one capacitor. I think half a stack or so will be enough of these for now. We can go ahead and craft up our connectors, and to start we'll just make small connectors. Each connector type has one of two current ratings. The small connector is rated for low current transfer, and the large connector is rated for high current transfer. What does that even mean though? Well, I've got something for you before we begin playing with electricity and try to harness lightning. I'd like to give you a bit of an explanation on electrical theory and why this matters. I want you to visualize a hose and then turn it on. When you turn that hose on, the water begins to flow, and dependent on the water pressure, that water is going to flow faster or slower. The hose represents the wire, and the water pressure represents the voltage. When you have higher voltage, there's more force pushing the electricity through the wire. If we turn a hose off and we go get a wider diameter hose, and then we turn it back on, there's more space for that water to flow. Therefore, a higher volume of water will flow through that hose. It's the same if we have a bigger wire. The current increases. If it's smaller, the current decreases. This current is measured in amperage. Fun fact, less than 1/3 of an amp is enough to stop your heart, so be extra careful around any open wires. You never know what you're dealing with unless you've got the proper equipment. Now let's pretend we kink the hose and cut its flow in half. The pressure builds as the water struggles to flow through the hose and escape, which represents resistance. Different types of wire have higher or lower resistances, controlling how much electricity is transferred. This resistance is measured in ohms. It's important to note that each of these units of measurement vary depending on materials and ultimately the power requirements and transfer needs of the project or machine. This is important to understand because there are scenarios where we have a machine that requires more or less voltage, which means we need the right combination of voltage, amperage, and ohms. Hypothetically, if we were to connect a low current, low resistance wire to a high voltage machine, the wire is going to superheat because the resistance is too low and allows too much power to flow through said wire, which typically results in the wire burning up and causes damage to all of the equipment responsible for transferring that power and all the equipment connected to that power. For all intensive purposes, our electricity itself is represented by the water, and the power is the total amount of energy transferred over the total duration of transfer. The total amount of energy transferred over the total duration of transfer is referred to as wattage. Over distance, the transmission of electricity comes with loss. The higher the resistance is, the more the electricity has to work in order to travel. Therefore, it burns some of itself off and dissipates. This is referred to as voltage drop, and it's directly associated with Ohm's law. In GregTech and immersive engineering, this is actually a feature of the mods, and it can leave you scratching your head if you don't know how electricity travels or how it's connected. I used to work in the electrical power line industry, and I've gotten to work with voltages ranging from 60 volts all the way up to 500,000 volts. And I'll tell you, this information is incredibly important if you don't want to microwave yourself. If you enjoyed that little lesson on electrical theory, let me know in the comment section. And if you have any experience working with electricity, share one of your favorite memories or most interesting experience while at work. I always love hearing other people's stories about electricity because there's so many crazy things that can happen, and it's the one element that we as humans haven't figured out how to harness completely. At the end of the day, it's the theory of electricity, and boy does it make us scratch our heads sometimes. Now knowing how the power is getting from the generation source to the plug in the wall powering your PC, you can probably assume that if we make low current connectors, they're going to have a different material makeup than the high current connectors. And you'd be right. Let's go ahead and craft up both. Starting with small, low current connectors, we need copper rods and copper wire as our conductive materials. Copper as a metal has a low resistance, allowing the power to flow through it very easily. And given the low resistance, the current is higher and its conductivity is significantly higher than certain other metals. Moving on to large, high current connectors, we need gold rods and gold wire or electrum wire as our conductive materials. Gold has a slightly higher resistance than copper, but it's more malleable, allowing it for better connections. In the real world, gold is typically only used in small form factor connections or PCBs and things of the sort. And here it's just more of a tier thing. Copper is the go-to lower voltage option in most places. For high voltage, the best metal to use is actually aluminum. Now that we've got our connectors crafted up, let's make the place we're going to store our power in, the accumulator. These work just like item vaults and fluid tanks. You can make up to a 3x3x32 multi-block that increases the volume of power stored. I'm going to craft 3 of these as that should make us a decent buffer of power for now, but to craft 1 of these we need 2 capacitors, 1 brass casing, 1 copper rod, and either 1 electrum wire or gold wire. Now we're ready to craft up our alternator and hook it up to our windmills. Go ahead and make sure you've got 1 andesite alloy, 1 iron rod, 1 capacitor, 6 iron plates, and 3 copper wire. Then let's head back to our mechanical crafters and then place the items in the pattern that we went over earlier. As this works, you can see all of the items move together and eventually pop out into the chest here. Now we're ready to hook this alternator up. However, we need to step the speed up or else this thing's not going to make us the power we need. So, to begin, I'm just going to do a basic ratio here, and we're going to get this stepped up to 256 RPM. This should be it. Might be able to connect 1 more. Yes, I can. Okay. Past that. Okay, this is max speed right here. Now, what we're gonna do is place our alternator on the front. You can see we're making 360 FE per tick. Now, this isn't a lot of power, but for what we need right now, just getting started, this will do. Next up, we're actually going to use our connectors and our accumulator, and we're going to connect this. So the first thing I'm going to do, I've already kind of made a little pathway down here that runs power into our main building, but we're going to place our accumulators down right here. And you can see there's a capacity of 6 million FE. That's a pretty decent amount to start with. So to get power from here to here, we're going to use our connectors. And we're going to place our small connector right here. And you'll see it says pull. There's 3 modes. You have pull, push, and none. Now, since this is connected to the power source, we want it to say pull, because it's going to pull the power out. Then on this side, on the accumulator, we need to get the power in. So let's go ahead and put another connector on here, but this one is going to be set to push. Now we can connect our copper spool from this connector by right-clicking to this connector. And you'll see our accumulator is starting to build power. We're going to let this build all the way up to 6 million. And for most of our beginning processes, this should be just enough power to get started with, like charging our jetpacks or charging certain building tools, stuff of that nature, or even just making simple new technological advancements. So I'm gonna go ahead and let this build all this power up, and then I think that'll just about wrap up this video. I'll see you in the outro. Next episode, we're gonna begin working with this electricity, and I think it's time we go find ourselves some aluminium before we get too ahead of ourselves. I really hope everyone enjoyed today's video. It's been a few weeks because I've been battling my allergies, and I don't want to sound like a dying walrus in y'all's ears. With that being said, you're all great. Remember that. Have a great rest of your day. Peace.